We walk on secrets every single day. Beneath your feet right now, under the concrete and asphalt, lie technologies so advanced that modern engineers cannot replicate them. Roman harbors that heal themselves after 2,000 years. Greek computers that tracked planets with gears machined to millimeter precision. Chinese earthquake detectors that sensed tremors 400 miles away. Batteries built before anyone supposedly knew what electricity was. Damascus steel with carbon nanotubes that would not be understood for 17 centuries. Concrete that gets stronger in seawater while ours crumbles in decades. These are not myths. These are documented facts sitting in museums, analyzed in laboratories, published in peer-reviewed journals. The question is not whether they existed. The question is how we forgot. If you value documented engineering and material science history like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from MIT's Department of Civil and Environmental Engineering Research, published in Science Advances in 2023 and Nature Communications in December 2025, and the Journal of Near Eastern Studies at the University of Chicago. Now back to the information. Volcanic ash, measurement tools. Masick and his team from Harvard University and laboratories in Italy just confirmed what skeptics said was impossible. The Romans made concrete that repairs its own cracks for 2 millennia. Roman harbor breakwaters at Caesarea, submerged in seawater since 22 to 15 BCE. The concrete has not deteriorated, it has strengthened. Modern concrete exposed to salt water fails within 50 years, sometimes 20. The difference is not subtle, it is absolute. The Romans shipped it across their empire in quantities exceeding 52,000 tons for a single harbor. 100 to 150 boatloads. Ships returning from Egypt after delivering wheat brought the ash back. But volcanic ash alone does not explain the self-healing. The breakthrough came from white mineral clasts, lime chunks previously dismissed as sloppy mixing. Researchers called them evidence of poor quality control. They were wrong. When cracks form and water seeps in, the lime dissolves. Calcium carbonate crystallizes. The crack seals itself automatically, over centuries. Vitruvius wrote the first known book on architectural theory, De Architectura. His process was different. Room temperature mixing. That concrete was for decoration. For load-bearing walls, the Romans used the hot method. Experimental data confirms quicklime and volcanic ash create aluminum tobamorite when exposed to seawater, a rare mineral that grows inside the concrete, strengthening it year after year. There are 35,000 cubic meters of Roman concrete in the Caesarea harbor. 24,000 cubic meters of that is volcanic ash. The structure has survived earthquakes, volcanic activity, saltwater corrosion, 2,000 years of Mediterranean storms. Modern concrete requires constant maintenance. Ancient Roman concrete improves with age. The aqueducts still carry water. The roads still bear weight. Buildings constructed with Portland cement, invented in the 1700s, crumble after 75 years. Roman marine concrete from the 1st century BCE remains structurally sound underwater. The chemistry is not mysterious anymore. The manufacturing process was documented on December 9th, 2025, in Nature Communications. We know how they did it. We simply do not build this way. The economic pressure favors fast construction over longevity. Roman concrete took time. It required specific volcanic materials. Hot mixing demanded expertise, but the result was infrastructure that survives millennia. That is not legend. That is material science. Athens, Greece. Sponge divers pulled it from a shipwreck off the Greek island of Antikythera in 1901. For decades, no one understood what they were looking at. Then researchers x-rayed it. The images revealed gears, dozens of them, machined with millimeter precision, triangular teeth like a modern clock, inscriptions describing planetary motions, a ring divided into degrees. Nothing else like this exists from antiquity. Nothing remotely close appears again for over 1,000 years. The front displayed celestial time. The back housed 2 spiral dials. One reconciled the lunar month with the solar year. The other predicted solar and lunar eclipses. All of this in a wooden case the size of a mantle clock. Hand-cranked, portable. The Greeks explained this with geometric theories. The Antikythera mechanism mechanized them. It required understanding of differential gears, previously thought to be invented in the 16th century. The device had over 30 interlocking bronze gear wheels. Each gear wheel represented a celestial body or cycle. The precision of the gear teeth suggests the use of vertical lathes and bow drills, tools that existed in ancient Greece but were never documented at this level of mastery. Fringe writers like Erich von Däniken claimed it came from aliens. Scholars filed it away. But the evidence did not disappear. Michael Wright, former curator at London's Science Museum, built working replicas using ancient methods. In 2006, researchers used advanced imaging to decode inscriptions hidden inside the fragments. A user's guide, instructions for operating the device, references to 462 years for Venus and 442 years for Saturn, ancient Greek calculations for synodic periods. Adam Wojcik, a material scientist at University College London, admitted his faith in Greek technology faltered at the tubes. Modern manufacturers use lathes to carve metal with that precision. Ancient Greeks did not have lathes of that sophistication, yet the device exists. In July 2024, researchers used gravitational wave analysis techniques to study the calendar ring. Graham Wone and Joseph Bailey published findings in the Horological Journal. The ring likely contained 354 holes. A lunar calendar, 354 days. The ancient Egyptian calendar followed lunar years. So did Islamic calendars, still used today. The precision of the holes required steady hands and accurate measurement tools, each hole positioned to a fraction of a degree. The shipwreck dates to the 1st century BCE. The vessel was en route from Asia Minor to Rome. It carried statues, amphorae, luxury goods. The Antikythera mechanism was among them. Who built it? The workshop of Posidonius in Rhodes is one theory. Cicero described a similar device made by Posidonius in the 1st century BCE. Another candidate is Archimedes. Cicero also wrote of a bronze mechanism made by Archimedes in the 3rd century BCE. Pappus of Alexandria stated Archimedes wrote a now-lost manuscript titled On Sphere Making. Hipparchus, an astronomer in Rhodes around 205 BCE, may have worked out the mathematics. He blended Babylonian arithmetic with Greek geometry. The eclipse cycle used in the device is Babylonian and begins in 205 BCE. Researchers continue searching the wreck site for more fragments, but what exists is enough to prove the ancient Greeks possessed mechanical technology centuries ahead of its documented appearance in medieval Europe. The Antikythera mechanism was not a one-off. Evidence suggests a tradition of complex devices. A geared calendar from the 5th or 6th century Byzantine Empire has been found. Al-Biruni described a similar device around 1000 CE. A 13th century astrolabe contains comparable gearing. The knowledge was transmitted, then forgotten, then rediscovered. The mechanism proves that technological progress is not linear. It advances, it stalls, it disappears, it resurfaces. The gears still turn in the fragments. The knowledge still waits in the bronze. Blades forged in the Near East using steel called woots from southern India. The swords displayed distinctive wavy patterns across their surface. They could be sharpened to edges so fine they reportedly cut silk falling through the air. Legends claimed they sliced through rifle barrels. That part was exaggeration, but the steel was extraordinary, tougher than anything else produced for 14 centuries. Then production stopped in the early 1700s. The method was lost, the ore deposits depleted. Modern metallurgists still cannot replicate it exactly. Or from Damaski, a type of swordsmith. The etymology is contested. What is not contested is the steel's properties. In 2006, a German research team analyzed Damascus blades using scanning electron microscopy. They found carbon nanotubes and nanowires in the steel, structures 1 to 50 nanometers in diameter. These formations are centuries ahead of modern materials science. The nanotubes likely formed from plant fibers added during forging. Organic material introduced into the molten metal, the carbon from the plants aligned into tubular structures during the heating and hammering process. This strengthened the blades at a microscopic level. Trace elements that affected crystallization during cooling. When those deposits ran out, swordsmiths could no longer produce the same steel. Attempts using modern ore fail to match the original properties. The exact mineral composition of the original deposits is unknown. The mines are exhausted. Researchers can approximate Damascus steel. Modern alloys exceed it in strength. But the precise replication using ancient methods and materials is impossible. The raw ingredients no longer exist in the same form. This is not a lost technique. This is a lost material. The knowledge was never written down comprehensively. Mastersmiths taught apprentices in person. Secrets stayed within families or guilds. When the ore ran out and the masters died, the method died with them. Museums hold Damascus swords dating from the 3rd century CE to the 17th century. Each blade shows the characteristic pattern. Wavy lines rippling across the surface. The pattern comes from carbide banding, alternating layers of steel with different carbon concentrations. This creates the visual effect and contributes to the blade's strength, flexibility, and hardness in the same material, a sword that holds an edge but does not shatter. The metallurgy is sophisticated. The carbon content sits between 0.8 and 1.7%. High enough for hardness, low enough for workability. The forging process involved repeated heating and hammering, folding the steel to distribute carbon evenly, then controlled cooling to set the carbide structures, temperature control without modern pyrometers, timing judged by eye, color of the metal, sound of the hammer. Skills developed over generations. Damascus steel represents the pinnacle of pre-industrial metallurgy. It was not surpassed until the 19th century with the development of crucible steel and later stainless alloys. For 1400 years, it was the finest steel on earth. Then it vanished. Sticky fire that clung to ships and could not be extinguished. The Byzantines deployed it through bronze tubes mounted on warships. Siphons sprayed the liquid at enemy vessels. It ignited on contact. Flames spread across the surface of the sea. The weapon saved Constantinople during 2 Arab sieges in the 7th century. It terrified naval forces for 600 years. Then use of Greek fire disappears from historical records after the 13th century. The formula was a state secret. It was lost. Only the emperor and select craftsmen knew the full formula. Revealing it was treason, punishable by death. The secrecy is why the formula was lost. Too few people knew it. When they died, the knowledge died. Historical accounts describe Greek fire as a petroleum-based mixture, likely naphtha or crude oil, combined with other chemicals to make it sticky and enhance combustibility. Theories suggest quicklime, niter, or sulfur as additives. Quicklime reacts violently with water, producing heat. This could ignite the petroleum when it hit the sea. Sulfur lowers the ignition temperature. Niter provides oxygen to sustain burning. But napalm was not perfected until World War II. If Greek fire was similar, the technology was lost for over 700 years. Some historians argue the weapon was simply petroleum cetellite, not particularly sophisticated, but contemporary accounts describe properties that exceed simple burning oil. The fire could not be extinguished with water. It burned on the sea surface, it stuck to whatever it touched. Ships, soldiers, stone. These characteristics suggest a more complex formulation. They would close with enemy ships and spray Greek fire across the decks. The psychological impact was immense. Enemies feared the weapon as much for its unstoppable nature as its lethality. Accounts from Arab forces describe the terror of facing Greek fire. Flames that could not be doused, water making it worse. The only defense was to avoid it entirely. The last recorded use is in the 13th century. Why did it disappear? Several theories exist. The empire weakened. Resources dwindled. The knowledge holders died without passing on the formula. Alternative weapons emerged. Gunpowder arrived from China. Cannons replaced incendiary liquids. Greek fire became obsolete, or the raw materials became unavailable. If specific petroleum sources or chemical components were required, losing access would end production. The exact reason is unknown. What is certain is that the formula was never written down comprehensively. No surviving Byzantine text gives the full recipe. Later attempts to recreate it based on descriptions have produced flammable liquids, but none match the reported properties exactly. Greek fire remains a chemical mystery, a weapon that dominated naval warfare for centuries, then disappeared without a trace. The device did not record seismic data like modern instruments. It indicated that an earthquake had occurred in the direction it came from, one of 8 directions. This was revolutionary. China experienced frequent earthquakes in remote regions. The emperor needed to know where to send aid. Zhang Heng's device solved that problem. 8 dragons attached to the outside, facing the 8 cardinal directions: north, south, east, west, northeast, northwest, southeast, southwest. Each dragon held a bronze ball in its mouth. Below each dragon sat a bronze toad with its mouth open. When an earthquake occurred, one dragon would release its ball. The ball would drop into the toad's mouth, making a loud sound. The direction the dragon faced indicated where the earthquake originated. The mechanism triggered only once per event. A single ball dropped, no others. Levers connected to the pendulum would activate one of the 8 dragons, releasing its ball. The challenge is that distant earthquakes produce subtle ground motion. A pendulum sensitive enough to detect tremors 400 miles away must also be stable enough not to trigger from local vibrations: wind, foot traffic, animals. The device had to distinguish seismic signals from noise. Modern replicas struggle with this balance. Zhang Heng's seismoscope proved itself in 138 CE. A ball dropped from the dragon facing west. No one in the capital of Luoyang felt any tremor. Officials were skeptical. They mocked the device as a failure. Days later, a messenger arrived from Longxi, a region 400 miles west of Luoyang, in what is now Gansu province. An earthquake had struck there. The timing matched the moment the ball dropped. Suddenly, the court was impressed. The device worked. This account is documented. It is not folklore. The seismoscope detected an earthquake the capital did not feel. Modern analysis suggests the quake was magnitude 7 on the Richter scale. A significant event. The distance and sensitivity required to detect it are remarkable for the 2nd century CE. Xindufang in the 6th century, Lin Xiaogong in the 7th century. Both received imperial patronage for their seismoscopes. But by the Yuan dynasty, 1300 to 1368 CE, all examples had been lost. Scholar Zhou Mi noted around 1290 that even the books describing their construction were gone. The technology disappeared. Attempts to reconstruct Zhang Heng's seismoscope began in the 19th century. None matched the historical descriptions for accuracy and sensitivity. In 2005, researchers at the Chinese Academy of Sciences built a functioning replica. They tested it against simulated earthquakes based on real events in China and Vietnam. The replica detected all of them. The data matched modern seismometers. This proves the concept was sound. Zhang Heng's original design remains partially mysterious, but the principle works. The ancient Chinese believed earthquakes were signs from heaven, displeasure with the emperor. Zhang Heng took a different view. He believed earthquakes were caused by winds and changes in air pressure. Wrong mechanism. But his approach was empirical. Test and observe, build and refine. That mindset produced a device that worked. The seismoscope is lost. The knowledge survives in historical records. In July 2025, researchers in China announced plans to rebuild the device using only Han Dynasty methods and materials, to restore a lost legacy, to acknowledge early Chinese contributions to science that predate the West by over 1,700 years. The work continues. In 1936, workers constructing a railway uncovered ancient graves. Among the artifacts was a ceramic pot, 14 centimeters tall. Inside the pot, a copper cylinder. Inside the cylinder, an iron rod. The components were sealed with asphalt. Wilhelm Koenig, then director of the National Museum of Iraq, examined the object in 1938. He proposed it was a galvanic cell, an ancient battery. The suggestion was controversial. It remains controversial. Mythbusters in 2005 built replicas using lemon juice as the electrolyte. 10 jars connected in series produced 4.3 volts. They successfully electroplated a small copper token with zinc. 5 jars delivered a painful current through acupuncture needles. 10 jars were insufficient to shock dry skin. The experiment proved the device could generate electricity. But proving it could and proving it did are different things. Gerhard Eggert showed that a similar technique used by Baghdadi silversmiths in 1938 was nearly identical to a process invented in Birmingham, UK in 1839. Not an ancient method, a modern one. Containers meant to protect against demons. The Baghdad battery was found in association with such bowls. This suggests a ritual or religious purpose, not electrical. Brad Hafford of the University of Pennsylvania noted that the iron rod could have been used to secure the contents, a scroll holder, nothing more. Professor Elizabeth Stone of Stony Brook University stated in 2012 that she does not know a single archaeologist who believes these were batteries. The consensus is skeptical. Bronze and iron needles have been found alongside the jars at Seleucia. This supports the medical theory. Acupuncture-like treatment using mild electrical current. Kaiser noted that Mesopotamian medical practice included elements conducive to such a device. Whether the battery was used for electroplating, electrotherapy, or ritual purposes is unknown. What is clear is that the artifact can function as a battery. The chemistry works. The components are correct. If it was intentional, it represents knowledge of electrochemistry 2,000 years before Alessandro Volta invented the first documented battery in 1800. If it was accidental, it is a curious coincidence. The jars exist. Most were lost or destroyed during the Iraq War. Looting damaged the National Museum of Iraq. Many artifacts disappeared, the Baghdad batteries among them. What remains are photographs, test results, replicas. The mystery endures. Tiberius asked if anyone else knew the secret. The glassblower said no. Tiberius had him executed. The emperor feared the material would devalue gold and silver. If glass could be flexible and unbreakable, it would replace precious metals. The economy would collapse, so the knowledge was destroyed, along with the craftsmen. But no physical evidence of flexible glass exists. No samples, no fragments, no documentation of the process. The material may have been a legend, or it may have been real and lost. Modern materials, science has produced flexible glass. Gorilla Glass, used in smartphones. Willow Glass, developed by Corning. These are thin, chemically strengthened glass that can bend without breaking. If the ancient Romans had a version, it was likely thinner or treated differently. The exact composition is unknown. The technique is lost, if it ever existed. The Portland vase is an example. 1st century CE. Cobalt blue glass with white relief. The craftsmanship is extraordinary. Glass blowing itself was a Roman innovation. They mastered it by the 1st century BCE. If they could control glass thickness and chemical composition, flexible glass is plausible. But without evidence, it remains speculative, a tantalizing possibility. A cautionary tale about suppressing innovation, or a myth. The truth is buried with the glassblower. Resonant, perfect. Modern luthiers cannot replicate them. Despite advanced tools and analysis, Stradivari's violins remain superior, or so the legend goes. The wood he used came from the Maunder Minimum, a period of reduced solar activity from 1645 to 1715. Colder temperatures, slower tree growth, denser wood. The spruce from the Alps had tighter grain. This affects resonance. The varnish is another factor. Stradivari's formula is unknown. Chemical analysis shows mineral content, ground glass, volcanic ash possibly. The varnish was thin. It preserved the wood's natural vibration. Modern varnishes are thicker. They dampen sound. The craftsmanship itself was extraordinary. Stradivari hand-carved each instrument. He adjusted thickness and curvature to optimize acoustics. No two violins are identical, each one tailored. But the exact combination of wood, Varnish and craftsmanship that Stradivari used is difficult to replicate. The wood from the Maunder Minimum is gone. Trees do not grow that way anymore. The climate has changed. The varnish formula is lost. Stradivari did not write it down, or if he did, the records are lost. We can approximate. We can come close. But exact replication is elusive. The violins themselves exist. They are studied, measured, analyzed. Yet the complete process remains out of reach. This is not a matter of technology. This is a matter of materials and individual skill. Stradivari's hands are gone. His methods partially documented. The instruments endure. The knowledge is fragmented. 12-sided shapes with circular holes on each face. The holes vary in size. Knobs at each corner. Intricate and deliberate. But their purpose is unknown. No Roman text mentions them. No inscriptions explain them. They are found in Gaul, Britain, the Rhineland. Never in Italy or Rome itself. This geographic distribution is puzzling. Were they tools, toys, religious objects, measuring devices? Every theory has problems. Suggestions include candlestick holders, dice, surveying instruments, knitting aids, or even weapons. None fit perfectly. If they were tools, why no instructions? If they were common, why no references? The objects are well made, expensive to produce. They would not be discarded casually, yet they appear in hoards and graves. Some are ornate, others plain. The variation suggests individual craftsmanship, not mass production. Modern replicas have been tested for various purposes, none conclusive. The dodecahedrons remain mysterious, a technology whose function is lost. Not because the objects are gone, because the context is gone. We have the artifacts, we lack the explanation. Roman dodecahedrons are a reminder that physical evidence alone is not enough. Understanding requires context, purpose, documentation. Without written records, even common objects can become incomprehensible. The knowledge buried with the users. He named it Mithridatium. The substance became famous. Nero's physician later refined the formula. It was used for centuries. Then the recipe was lost. What remains are partial ingredient lists. Opium. Low-dose combinations of toxins and their antidotes. Exactly how it worked is unknown. Vaccination follows a similar logic. Controlled exposure to build immunity. But a universal antidote is implausible. Different poisons work through different mechanisms. A single substance cannot counteract all of them, yet historical accounts claim Mithridatium worked. Was it placebo, partial effectiveness, or did it contain a broad-spectrum binding agent? Activated charcoal is a modern universal antidote. It absorbs many toxins through ionic interaction. Could Mithridatium have included something similar? Possible. But without the formula, speculation is all we have. The knowledge died with Mithridates and his successors. The concept survives. The specifics do not. Catapults, grappling hooks, and allegedly a heat ray. Mirrors focusing sunlight onto enemy ships. The concentrated light ignited the sails. Ships burned, Romans retreated. The story is repeated by ancient historians, Lucian, Galen, and Anthemius, but no detailed descriptions survive. Did Archimedes actually build a heat ray, or is it myth? They used mirrors to focus sunlight on a wooden boat in San Francisco harbor. The boat caught fire, the experiment worked, but conditions were controlled. Clear sky, stationary target, precise alignment. In battle, these conditions are unlikely. The target moves, the sea reflects light. Smoke obscures vision. A practical heat ray would require many mirrors, coordinated positioning, trained operators, complex logistics. Some historians are skeptical. They argue the story is legend, embellished over time. Others point to Archimedes' documented inventions. His understanding of optics and geometry. He invented the Archimedes screw, the compound pulley, a planetarium device similar to the Antikythera mechanism. A heat ray is not beyond his capabilities. But without physical evidence or detailed accounts, the truth is uncertain. The concept is plausible. The execution is doubtful. Archimedes' legacy is secure. The heat ray remains a question mark, a technology that may have existed, or may have been a story told to boost morale. We do not know. Heat gold and mercury into an amalgam. Apply to the surface. Heat again to evaporate the mercury. Gold remains. But some objects show characteristics inconsistent with fire gilding. The gold layer is thinner, more uniform. Chemical analysis finds no mercury residue. This raises the possibility of electroplating, using electrical current to deposit metal onto a surface. If the Baghdad battery was real, this is how it could have been used. 1 to 2 volts is sufficient for electroplating small items. No electroplated objects definitively linked to the batteries have been found, but the absence of evidence is not evidence of absence. The technique may have existed, then lost, but the result matches some ancient artifacts. The problem is proof. Without finding an object with clear electroplating signatures from the correct period, the theory remains speculative. The objects exist. The method is possible. The connection is unproven. This is the nature of lost technologies. Fragments of evidence, possibilities, gaps. We piece together what we can. We acknowledge what we do not know. These 12 technologies span 2 millennia. They come from Rome, Greece, China, the Near East. They represent engineering, chemistry, metallurgy, astronomy, materials science. Some we have rediscovered: Roman concrete, the Antikythera mechanism. Others remain partially understood: Damascus, steel, Greek fire. Some may never be fully recovered. Flexible glass, Mithridatium. The pattern is clear. Technological knowledge is fragile. It depends on documentation, transmission, continuity. War destroys it. Secrecy hides it. Time erodes it. We assume progress is inevitable. That knowledge once gained is never lost. History proves otherwise. That is the exception. Most lost technologies leave no such record. The methods die with the masters. The recipes are never written. The knowledge fades. We are left with artifacts and questions. The objects prove they could. The absence of documentation proves they did not pass it on. The lesson is not that ancient peoples were more advanced than we think. The lesson is that advancement is not permanent. It requires effort to maintain. Knowledge must be shared, documented, preserved. Otherwise, it disappears. The gears corrode, the concrete crumbles, the scrolls burn, and we stand in the ruins, trying to remember how it was done. The concrete was not mixed carelessly. It was engineered. Precise ratios of quicklime to volcanic ash, controlled temperatures during mixing, specific curing times. This was not trial and error. This was science. Applied knowledge passed through generations. When the eruption came, the workers left their tools. The knowledge scattered. For 2,000 years, we walked past Roman buildings without understanding. Now we know. The lesson is simple. Write it down. Teach it widely. Do not let it become a secret, because secrets die. What we lost was not the capability to understand. We lost the knowledge that it had been done. The Antikythera gears turn. The Roman concrete hardens. The Chinese seismoscope waits. The Baghdad battery sits in fragments. These are not relics. They are evidence. Proof that we have forgotten more than we remember.